Hello and welcome to Vodcast 13.5. In this podcast, I will overview 4 different types of local winds. Before we get into local winds, I'd like to remind you that all winds are produced for the same reason: pressure differences that arise due to temperature differences caused by the unequal heating of Earth's surface. Water is extremely good at maintaining relatively consistent temperatures. On the very hottest of days, water's temperature won't go up too much. And even on the very coldest of days, water is very good at resisting temperature change. However, on a hot day, land can heat up rapidly, and during cool periods, land can cool down rapidly. So when we reference the unequal heating of Earth's surface, that's basically what we're talking about. The central concept in all 4 of these local winds that we're going to talk about today is land's ability to heat rapidly and to cool rapidly. Now, local winds are small-scale winds produced locally by pressure gradients. The first 2 I'd like to overview are land and sea breezes. A sea breeze develops because cooler air over water will move towards the land. During really warm summer months, the land will be heated much more rapidly than the nearby water. And when that land surface gets heated, the air above the land surface will get heated, it will expand, it will rise, and it will create an area of low pressure. So in the image you see in the center of this slide, the red L you see over the land indicates low pressure due to the fact that the air over the land is heating and rising. Now, if we focus on the air over the cooler water, it will be in a region of high pressure because the water surface isn't heating like the land surface was. So what occurs is a sea breeze, and whenever we name winds, the name will always describe where the wind originates. So what we see in this image is a sea breeze because the wind is originating over the sea. If you look at what's happening aloft, you can see cloud formation over the top of the low pressure region, because that rising air can cool adiabatically and form clouds. But very high aloft over the low that's occurring on land, we have a high pressure region, because there is already air up in that region to begin with, and if we're adding more air to that region, we will now see a high pressure zone. So if we focus on what's going on aloft, we actually see airflow from land out to sea, and this whole process forms a very nice cycle. Now, sea breezes tend to occur during the daylight hours, when land can heat up. But at night, land will cool rapidly, whereas the water will maintain a relatively consistent temperature. So in the image you see on the right, we are looking at what's known as a land breeze. Now, with land rapidly cooling, we see high pressure located over the land surface. But over the top of the water, which is now comparatively warmer, we start to see air rising, and that produces a low pressure region over the water. As a result, the winds will now blow off of the land and onto the water. These land and sea breezes occur most commonly near oceans, gulfs, and very large bodies of water. But they're also notorious for affecting the winds in Chicago, because with Lake Michigan right nearby, the exact same day and night wind dynamics can occur. But one really nice thing about sea breezes, no matter where you're located if you're experiencing them, is that they bring relatively cool air coming off the water to land. So in a sense, they kind of act like natural air conditioning. The final 2 types of local winds that I'm going to overview are valley breezes and mountain breezes. Let's start off by looking at the valley breeze. During the daylight hours, solar energy will heat the mountain slopes. And if you look at air at the same elevation over the top of the valley floor, that air won't be heated as much, because that air sits higher than the valley floor. But the air sitting just over the top of the mountain slopes will be heated, it will expand, and then it will rise up the sides of the mountains. With that rising warm air up the mountain slopes, cooler air will sink into the valley. And there's very important visual evidence to consider that shows valley breezes are occurring. If you see the formation of cumulus clouds near the top of the mountain, we know that those clouds are forming because that warm air rising up the sides of the mountains is adiabatically cooling and forming clouds. But after sunset, things change. As the mountainsides cool rapidly, the air just over the top of the mountainsides will become more dense as it cools, and it will sink into the valley. As that cool, dense air sinks down the mountainsides, it will force the warm air from the valley aloft. When this process occurs, we have a mountain breeze. So in summary, valley breezes occur when air on the mountainsides glides upslope after it's been heated, and valley breezes will occur during the daytime. But mountain breezes occur as the mountain slopes cool, and that cool, dense air that resides just over the top of the mountain slopes will sink and drain into the valley. Okay, that concludes this video podcast. For the sake of quizzes and tests, be able to identify all 4 of these local winds based on their pictures and their descriptions. In our final vodcast for Chapter 13, I will describe the ways that we measure wind.